Thanks. So thanks for having me. I really appreciate your invite. I'm Nicolas Frankel. I've been working nearly 20 years in IT. I've held various technical positions, and since 2 years, I have stopped doing projects, and I'm a developer advocate. I work for a company called Hazelcast, and Hazelcast, if you don't know about us, basically we have two products. Our first product was in-memory data grid. And you can think about an in-memory data grid as like a data structure, but that can be distributed among several nodes. So basically you have a hash map, and then you have an interface that is very, very similar to that one of the map interface in Java, but then the implementation is distributed over the network. And Hazelcast Jet is part of this talk. So I won't tell it in detail now. I will probably like introduce it bit by bit afterwards. So our schedule today is why do we have streaming, and then a couple of streaming approaches. Then I will talk about Hazelcast Jet. And because I want to do a demo, I will also have a section about open data and something called GTFS. Then I will try to impress you with the demo, and then if you don't have if you were too shy to ask a question during the talk, you will still have another chance to ask a question at the end. So as I mentioned, I started working like 20 years ago, and 20 years ago it was already the time of SQL. So SQL databases, they were everywhere. There were like some mentions, some myth about object-oriented databases, but basically SQL was overall SQL database. So at the time I was using SQL Server from Microsoft. And then you would have specific use cases which were not really a good fit for SQL databases. I have like two use cases at least. So the one is analytics. Like I've worked for retailers at some point, and basically if you are a head of supermarket or head of a supermarket department, you want to have the sales of the last hour, every hour. Because if the sales are not great, you might want to do some promotion in the coming hour. So you want the numbers so you can make the decisions. Another need is basically at the end of the year, or perhaps at the end of the month, depends on probably on the country, or both. Your bank will send you a nice account extract, which tells you actually what happened on your account. So for both those use cases, SQL is not that great. And it all boils down to the following, is that in SQL databases, you are thinking about the writes as well as about the reads. And the fact that we are using SQL is we are focusing a lot on the correctness of the data and on the write. So you want to have data that is normalized, you don't want duplicates, you want to have constraints, you have to have joins, you want to have the normal forms, everything. Actually, when you want to do analytics, so the reporting or the analytics or this kind of stuff, you don't care about the correctness of the data because you don't write to it. So you assume that the data you will read from the data store is already correct, and you just want to read it as fast as possible. Because like, for example, the bank statements, you need to deliver it to all your customers, might take a lot of time. So you want to be as fast as possible. And in that case, SQL gets in our ways. So if you are using a SQL database to read fast, it's going to be a mess. So in general, what you do is you have different actors. So you have your application, normal transactional application that do the writes, that do the reads. And then you have an analytics database. And both have different constraints. And probably the one with the analytics use case, basically you have a lot of duplicated data, you don't have constraints, you don't have joins, you just put everything, and then it's just reading line by line. So the idea is to take data from the SQL database into, again, at that time, like 20 years ago, you put it in another SQL database, but which was completely denormalized, without constraints, without join. Everything was duplicated if needed. You didn't care. Great. And in order to do that, you have batches of ETL, extract, transform, load. And basically, if you have used Spring Batch, for example, or whatever, it's exactly what it's doing. And sorry, the batches are everywhere. I believe that everybody who is here in this talk has either seen batches or written batches, or obviously both. And when you start considering batches, batches have two properties. The first is they are scheduled at regular intervals. So about the analytics use case that I mentioned, it's hourly, and then they can run in a specific amount of time. And of course, when I've said that, again, if you have a bit of experience, you probably know of batches who start taking more time, and that basically overlaps to the next schedule. And at first, you are very happy with your batch. It runs like you have an hourly batch. It runs under 30 minutes. You are super happy. And then with time, you get more and more data, and it starts to get slower and slower until it gets to the next hour. And then you don't know what to do, because the next batch will also take more than an hour, and it's the beginning of the end. The thing with batches also is generally you need to load everything in memory to do the transforms. And so if you do that, sometimes it might happen that your memory is not big enough to get everything from the database. Something that can happen also, and I guess you already encountered that, is what happens if the batch fails during its execution. So if you are a bit lucky, you might have used transactions, which is good. So basically you roll back everything. But then if your batch like is an hourly batch and it takes 30 minutes and it fails at the 20th minute, and then again you run into the first problem again, that if you start it a second time, probably the end of the batch execution will overlap the start of the next one. So you have a lot of issues with batching. And one of the issue is basically is congruent to the SQL database. Most SQL database, at least the old one, they were basically master slave. So you could have replication, but the master was, well, it was the coordinator. You couldn't do anything else. So if you wanted to be faster, the only thing that you could do is vertical scaling. So you bought a bigger machine, more processor power, more RAM, whatever. But afterwards, at some point, you were limited just by physics. And to find that, there was this big movement called big data. And big data had different ways of looking at things. And so the basic foundation of big data is you can parallelize everything. So instead of having a database that has master and slave and replication, you could have different nodes, and then you could distribute the nodes among all, you could distribute the load among all the nodes and parallelize the work. And then you have horizontal scaling, and well, it can be close to infinity. Of course, it's not all unicorns and rainbows. There is a lot of waste. So the more nodes you have, the more waste you have, but still it's much, much better. And of course, you also need to think about what transform you will do, how to parallelize them, because some of them cannot parallelize, but yeah. And with big data came this NoSQL advance that basically said, oh, you know, if your data is only meant to be read, or if you have a lot more reads than writes, then basically we don't care that much about the constraints. and we put everything into the same place. We have duplication. It's fine, which was good at the time because, again, with SQL, it was, hey, everybody must use SQL databases. But in some cases, we just remove the stuff that makes SQL servers good, just as joins and constraints and transactions, for example. And of course, it went completely the other way. So nowadays, you find people that are happy to have no constraints because YOLO and this kind of stuff. So as every time, the truth might be a bit in between. Another way to handle the issues that I described before is instead to load everything in memory. Then you load only a chunk of it, and then you keep an offset, a counter from the chunk, and so you keep trace of what you already did process. Now you have other issue because meanwhile there might be new data coming in, so it might do not so great stuff about your cursor. But I mean, depending on the kind of data you want to handle, it can be an approach. And now came events. I suppose you are familiar with event-based programming. Like event-based programming found its root in the fact that when you are programming a GUI, basically you wait until something happens. You wait until the user like clicks or scroll or whatever. And an event is basically just something that happens and it's associated with like a timestamp. And so if you start looking at your data that comes in as events, then basically you can start thinking about making everything event-based. And you've got a lot of benefits. So the first one is, since you only like get each bit of data when it comes, then because it's a bit of data, you don't need to load your whole database into memory. You just need to handle the event. The event is much smaller, so it's very memory friendly. So instead of needing, I don't know, like 25 gigs at once, you just need, and let's say like 10K at a time. So it's better. You don't need to handle peaks. For the same reason, you can process it more easily. And the good thing is, because you can manage them, you can handle events as soon as they arrive, then you have something that is very close to real time. And I think that's a real benefit. Like if I get back to the use case of the supermarket analytics, the problem that we have is, imagine that the batch that is scheduled hourly, it needs, let's say, 5 minutes to run, and you want to start it at the hour. So that means that during 5 minutes, you basically might want to do some promotion, but you have no clue because you don't have the data. So what you will do is you know that it takes 5 minutes, so you will start it like 5 minutes before the hour. And then when it's the hour, you will get the result. But that means that during that time, you will completely miss the 5 last minutes of the hour. So basically, your data won't be correct. So either you must accept that your analytics will be late, or you won't have the full big picture. So having the data coming in as soon as it arrives, you can already see the trend. And basically, the fact that it's an hourly batch, it doesn't mean anything. It's our view of the time. What you are interested in, hey, did I sell really great in the last hour, or in the last 30 minutes, or in the last 15 minutes? So when you get data as soon as it arrives, you have everything. You have a view of what happens, and so you can decide whenever you want. So you won't have the final latest data, but it's not a mathematical process. So perhaps you are not that interested in being like 100% correct. You might be interested in having enough data to take a decision, an informed decision. And once you start viewing your world in events, Then you start also having a view from finite data sets, so whatever is in my database, to infinite, because events, they will arrive for a long time and they will never stop happening. I don't know what, and let's say that we are talking about supermarket sales. There will be sales every hour and the next day, and perhaps you're open on weekdays or not, but so there might be a stop during the weekend, but then it will start again on Monday. And so basically you will have these infinite data sets always coming in. Something also that we might be interested in having is something called the stateful streams. So if you have an event and you are only interested in transforming the event to do something else, you can manage each event individually. But if you want to have this kind of analytics, then what you might want to be interested in is basically you want to keep track on previous events or previous property of previous events, and then start comparing the events to the previous event or to the last 10 events, or even better, to all events that happens in the 5 latest minutes, for example, and this is called windowing. So you have different kind of windowing window. You have windows that don't overlap, just like every hour, or you have sliding windows. Well, you have different kind of data, of ways to aggregate data. I won't talk in detail about it, but just think that what you can do with it. And basically, like streaming is this smart extract transform load. So you handle events individually instead of taking everything at once. And then you go through all your processing pipeline. And you can do a lot of stuff that you did in the previous batching. You can, like every event, imagine it as an ID. You can combine it, you can enrich it with the full properties of the object that this ID references. So you read from somewhere else and you enrich your event data. And then you, as I mentioned, you stream it, and you distribute it all over your nodes, because remember that we want to have everything distributed because we want to scale horizontally. And afterwards you write where you want to write. So this is another world where we can have a lot of use cases. So far the common use cases, they are real-time dashboards. You can have statistics, you can make predictions. So imagine that all this data can fuel a constantly updating machine learning model. Then you can have something that is reacting to what happens, and so it's training all over. It's really great. And if you remember, like 15 years ago, we had something called complex event processing, and at the time it was attached to an enterprise service bus. So basically, you were telling people, hey, look, if we have one event flowing through the enterprise service bus and we have another event, perhaps we can like compose those two events and start like inferring something. Well, you can do the exact same with stream processing, but now it has a fancier name. It's distributed. You don't need an enterprise service bus anymore. Once you see the things in event, probably you want to, as I mentioned, you want to transform the data, to filter the data. Everything that you do with Java streams, for example, you might want to do it with like data streams. There are two ways to look at things. The first is you will use something that is persistent. So in the Java ecosystem today, or not even in the Java ecosystem, let's say in the ecosystem in general today, the Kafka rules supreme. But there is a contender called Pulsar. You might be interested in knowing about it, because it seems for operational purpose to have certain properties that are lacking in Kafka. Anyway, so one way to handle the events are to store them. So I will talk about Kafka and just a few words. Basically, it's distributed. It stores the thing on disk. So that's very good, because you can use it like a pseudo database, something that, well, you can just store it. On the other side, because there is always a flip side, that means that if you want to do multiple transformations and you need to do the transformation right down to a new topic, and then you can do the transformation right down to a new topic, and this consumes a lot of I/O time. And the benefits of Kafka is basically the consumer keeps track of its offset. So basically, if you have slow consumers and quick consumers, then everybody is happy, because the slow one can be as slow as needed, and the fast one, they can be as fast as possible. So that's a big benefit. As I mentioned, there are like persistent event storage, and you can have like in-memory stream processing. And for example, you can have it on-premise. So Flink is one of them. Hazelcast Jet is another. There are a lot of others, of course. It's just a sample. On the cloud, you have Amazon Kinesis, you have Google PubSub. I just have a mention about Apache Beam, which I find interesting because it tries to be an abstraction, like over some of the above. So the basics concepts of stream processing are pretty close to one another. So it tries to have a unified API, so you could like remove one and put another one in its place. And because there is no API that is cross all stream processing engine, because there is no specification or governing bodies, it's very leaky, but I still think it's interesting in the way it tries to make your life easier and to be agnostic for you. So some words about Jet. So it's open source. Basically, it's found in a single jar. I will talk about the deployment model a bit later. And we are using Hazelcast IMDG under the cover. If you are more used to using batch API, just know that you can start with batching with Jet, and then you can move to streaming in a single line, and the rest of the code won't change. And of course, because we need, well, Hazelcast needs to pay also for me, we have an enterprise offering that is paid. Basically, those are the words that we use for stream processing inside of Jet. You might find different wording, different semantics in other products, but basically the concept will be the same. You have the pipeline, and basically the pipeline is declarative code, which describes what you will do. I will read from that, I will transform it from there, I will do some filtering and blah, blah, blah. And basically, once it's written, then you have a client that will take this code and it will send it to the stream processing engine, the SP stream processing engine. And the stream processing engine is responsible for the rest. It's responsible to execute the code and to distribute the load over all the nodes, and also to distribute the load over the processors inside. As I mentioned, it's a single draw. So if you are a Java developer, what you can do very easily is you can use it as a library inside your application. And so we have a Java API, and that means that when you start your application, you can create a new Jet instance, which basically will start the stream processing engine. And because we are using in-memory data grid under the cover, the IMDG provides a way for nodes to create a cluster. So basically, if you are on the same network, or basically if you can be on different network, but of course you need to configure everything. But by default, it will broadcast over the local network. And if you have several nodes, they will find each other and form a cluster. That's the easiest way to start with Jet. And if you are a Java developer, it's really great. Of course, it has a downside. If you need to scale your application because you need more processing power, that means that you will scale your application in parallel with the number of Jet nodes, and also they will share the same memory. And that's perhaps something that you don't want. So there is another way to do that, is basically you deploy your server. Like Jet can be also a server. And we have Docker images of what you want, Helm charts also if you are using Kubernetes, and then You have your application, which only has a client API, so only the jar of the client API, and then you have a different way to connect. Of course, now you go through the network, so there is a slight overhead, well, depending on your network, but now you can scale both independently. Another benefit of this deployment method is basically here, you see that there is a Java API, here there is a client API, because we have different APIs for different language stack. For example, we have Python, we have Golang, we have C# and C, and I'm probably forgetting one. But anyway, everything is on our website. So basically, in that case, you don't need to use Java to use Jet. So here, that is the implementation that I showed before. This is the list of all available connectors. So here to read and here to write. And the important stuff is if you don't find what you want, there is always an API to write down your own. The good thing also about Jet is basically, since we are leveraging Hazelcast INDG, what you can do is enrich from in-memory. Because if you use Hazelcast, well, any stream processing engine in memory to be very fast and not use Kafka in its place, you want everything to be as fast as possible, probably. You want to avoid to store everything on disk or to read from disk. But then if you want to enrich something from the database, then again, you will slow down your stream and your streaming. So what you can do, and in generally that's what you do, is at the beginning of the streaming, what you do, you like load everything into in-memory, and Jet will not read from the database, but read directly from memory. And that way it can be like very, it can improve your performance a lot. As I mentioned, Jet is able to parallelize your workload not only like inside a node on different processors, but also on different nodes. So there are some operations that it can distribute. And of course, if you know that a specific operation cannot be parallelized, like you have an API to let Jet know about, hey, this must run on a single node on a single processor, otherwise there will be an issue. So that's stream processing. And now for my demo, I need to have data. And because I want to use not data of Hazelcast, I want to have data that is freely available. And for that, there is something called open data. So basically, open data is to data what open source is to writing code. And the funny part is basically open source has been there for a long time, and I think it's pretty widespread now. I mean, everybody wants to do open source. Open data is much harder to come by. So there are laws to improve that, because governments, they want data to be free so that the private sector can use it and create value for the society, and not every company keeping its own data, or every administration. So I've written some stuff I know about. For example, in France, there is like an open data initiative, in Switzerland as well. The European has one also. Depending on your country, there might be one, there might be not, I don't know. However, it's not very fun to use these open data endpoints. And there are a couple of challenges that I just want to mention, because, I mean, forewarned is forearmed. The first is, if I tell you, hey, you have open data, you will think about a web service. Okay, it might be a SOAP web service, but probably it might be a REST web service, JSON, everybody's happy. Well, most of the time, administration, they'll let you download the file. So first challenge, I mean, how fresh is the data from the file? How many, what's the frequency in which the file is refreshed? I mean, that means that probably you will need to have a batch, or during your stream processing, you will need to download the file yourself. No fun. And then the formats. So again, I would infer that open data means open formats, but you can find Microsoft Words, You can find Excel files. If you are lucky, you will find PDF. Good luck with parsing the PDF to find the data. It's really fun. And of course, there are better formats, just as CSV, XML, or JSON, but basically it's the Wild West. The standards. Let's assume that we have a good format, like XML, for example. I really love XML, and I hate JSON because of the grammar, because like XML lets you like pre-validate the fact that it's correct data. It's just like constraints in the database. I want these constraints to be expressed in the like a more agnostic way possible. Anyway. So imagine we have XML. Hey, what is the grammar? So basically, if you want to do public transport, if you want to do medicine, if you want to do retailing, whatever, you would like everybody to share the same standard. Because if you want to aggregate different data sources from different providers, you want to have the same standard. In general, that's not the case. So you might know about the XKCD comic that, hey, there are 14 competing standards. I will create my own that will like cover all of them, and then soon you have 15 competing standards. And that's the last one, last challenge. You might have heard data scientists complaining that basically they are doing 20% data science and 80% data curation. Well, it's not only data scientists, and data engineers have the same issue. So for example, this is from my demo. And this is a file that I got from the provider, and this is a time. And if anybody can tell me what those means, like 25th hour of something, I don't know what that means. I mean, there can be many ways to handle that. You can say, oh, it doesn't exist. I forget about it. You can say, oh, but probably it's a mistake. It's the next day or whatever. But you have no clue. So you are just making inferences. Now I have everything. I just need my specification for public transportation. And so I would expect it to be like a public specification, but there is none. What there is something provided by Google. So at the beginning, I thought that GTFS was Google Transit Fit Specification, but it's just general Transit Fit Specification. And basically, it tells you how, as a provider, you should format your data so that they are interoperable with other. There are two things. There is the static model, and you can see there are a lot of files. And basically, I want to go into detail, but basically here you find all the stops, and then you find here the routes. So basically, it joins the stops. So you can imagine that here in this file, there is a reference to this file. Here you will have like stop ID 1 and stop ID 2 and stop ID 3 makes route A. And here you will have stop ID 1 with its like coordinates, and stop ID 2 and all the stops, this kind of stuff. You can see there are a lot. So this is the static model. And now what I want to do is I want to query the endpoint about the location of the vehicles. And this is what I get. This is a very, very huge model. And here is the route message. And if you read the model, you can see you have something called like feed entity. And here you have the vehicle position. And everybody is happy. So basically, you just need to get the message, to get all the feed entities. And every feed entity has 0 or 1 vehicle position. I've got the vehicle position. It's fine. I know where my vehicles are. So I was super happy. I go to the Swiss public transport. I get the open, it's an open data organization. They make everything available. Very happy also that the dynamic data is available as the REST endpoint. So just let's start using it. And this is the model that they provide. So they don't provide the full model. They provide this kind of stuff. And here, there is no vehicle position anymore. Here, there is nothing. So actually, you need to dig into the model and to understand how it's made. And here, they don't provide the vehicle position, but they provide something called a trip update that has multiple stop time updates. And every stop time update basically has a stop ID. And as a delay. So basically what you need to check is in the routes, you need to say, hey, here, I was supposed to be here at this time, but now, because of this delay, I will be here at this time. And so you can only like know the position of the vehicle by interpolating the position between two stops and the different delays on respective stops. And guess what? That's very cool, because that means you need to do computation, and it's a very good use case for stream processing. So here is my dynamic data pipeline, my stream processing pipeline. So I will read the data from the web service because I have here one single big message. I will split it into different trip updates, and after each step into the data pipeline, I will enrich it with data that I already preloaded from the static files in memory, because remember, I don't want to open the file every time. I want to like preload everything into memory and then be very, very fast. This step, the fifth step, transform hours into timestamp. It's because my front-end developers want in timestamp only. So this is the architecture. Here I have my Jet cluster, and here I have an app that defines the pipeline, and it will send the pipeline to the cluster. The cluster will transform that pipeline into a job, so an actionable pipeline. It will read the data files, and it will put them into the Hazelcast IMDG. Afterwards, when the Hazelcast IMDG is ready as every point of data, I will have this other job. And basically this job will be the one to call the open data endpoint, and will be the one to actually read the JSON and do all that stuff, and then store the final result into Hazelcast IMDG, into a different map. And then I will have a normal Spring Boot application that will register changes to, that will subscribe to those changes. And then it will send the events as a WebSocket endpoint to my front end finally. So now I hope that we can have the demo working, because it's always funny when it doesn't work, especially for me. So I already started the Jet cluster. There is only one node. I already loaded everything into memory because it takes a bit of time. Here, I don't know why it took really, really a long time. And now what I can do is I can run the stream data job. So this morning it worked. Now I must check that it's still working. Yes. And here you can see normally that it will start. Please do start. Don't do that for me. Yes. So here you have the result of what happens. Now I will start the web application. I think that Teams is taking quite a toll on my machine. I don't know why. Because my computer seems very, very sluggish. Sorry about that. It takes a bit of time. I don't know why. Perhaps I can have the monitor, application monitor, and kill every undue process. Wow, it takes a long time for everything. Now I'm wondering whether I should just instead play the movie. I will give it 30 seconds. If in 30 seconds it's not finished.
Yeah, I think don't worry too much. Yeah, let's give it a bit of time.
Okay. Yeah, this is expected. This is not expected. So Teams is really killing me. Okay. Hot swap. Hot swap, I don't like it when it hot swaps. I think I will rely on the movie. No?
I think as Forrest Gump said, different things happen.
Yeah, but here my computer seems like it's running in molasses, you know, like in.
Something is dealing at my end as well. So it's probably Microsoft Teams.
I think Teams doesn't do any good. Yes, that's for sure.
Okay, now your face is not frozen. Okay.
What can I close? I will have hard time closing anything here. Okay, if you don't mind, I will stop the demo because it takes too much, and I will just show the movie. Just believe me that it works. I was at the end of everything. Wait. I saw something. Yes.
You have found the key how to make things works. Just thread them. You will switch them off, and they will start to work.
Yeah, I will threaten them, and they will working. So here you can see the application joining the cluster as a client, and it tries to connect, and I hope that it will respond. Meanwhile, I will just say, hey, here I have the jet trains. Where is my jet train? So here I recorded a movie just in case this would happen. And because it's a bit sluggish now, I will probably, yeah, it takes too long. I will just kill it. So long, demo. GPS. GPS. Oh no! I just want to kill it. I'm really sorry about that. Yes, that's the demo, but it's a movie instead of being the real demo. So basically, I've loaded the map, and here you can see all the markers. The markers represent either a bus or a train or whatever. So if the line is red, it's a train. If the line is green, it's a bus. And you can see here what I told you about interpolating. So here you have two stops, and I had to compute the time between those two stops that the transport was in between. So the not so great stuff right now. So here I loaded the data from the static data files, because when I receive it from the web service, it's only an ID. Yeah, it's a straight line between two stops. I couldn't follow the road because I don't know how to use open leaflets as good as I wanted. But here you can see here the train like between two stops. And in general, that's a good way to have a good data visualization. You can see everything that happens in Switzerland at this moment, for example. So this is, I think that's a really cool use case for data streaming, this kind of stuff. Okay. In all cases, I will give you the repo so you can play with it if you don't trust me that it worked at some point. But I don't know. Yes, the application apps, the Teams app is taking a bit of resources. Okay, so that was the demo. So recap, streaming has a lot of benefits, especially if you leverage open data. However, just be careful, because depending on the open data that you want to use, you might run into a lot of challenges. But if you find the good source, if you curate the data points, then you can do really cool stuff. Well, at least according to me. So thanks for your attention. You can read my blog. You can follow me on Twitter. You can read more about Hazelcast Jet. Here you have the specifications for GTFS. And finally, you have the repo for the codes that I showed you. And if you are interested, perhaps also now that it's a bit better, we can have a look at the codes. Who would be interested in having a look at the codes?
You know, it's hard to get a response, but maybe, yeah, those who are interested, please write something in Q&A.
Yes, please.
Then we wait for half a minute.
Let's do that. It's Kotlin. Perhaps it might be more interesting or less interesting, but just let me know. Everybody is so shy. Nobody wants to answer anything.
No, what we just said, they will hear just in 20 seconds. So.
That's the reason.
Yeah, we have to wait at least 20 seconds while people hear, and then some more seconds while they react. So let's say in total, in 1 minute, we can understand is there any reaction or not. So code in studio.
Code in studio. No, I have IntelliJ. Sorry. So I will have codes, but I will have code anyway. So here, this is the load static module. So first, this is the data files, the static data files. So here, this is how they look, for example. And you can find perhaps some funny stuff. Not this one, but this one. Yes. So here, this is what I showed you previously. This open data endpoint gives you 24-hour. Okay, that's fine. But 24/15 is a bit strange. So I don't know what that means. So this is all the files that I loaded in memory just to get access to be very, very fast. And how to load them? Well, I've created, so I have this main stuff. I try to be very generic. So basically I have one job that will execute the reading of the stops, the agencies, the roads, the street, blah, 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 blah. And this is how I do it. So I have this, here I have No, that's not what I want to show you. I want to show you the pipelines. So here I have created something that I call the pipeline, and basically the pipeline is using the Jet API in a very generic way. So I want to have the same code, the same pipeline to handle all those different formats. So basically, I will read from the file that I pass in parameter, then I will do some cleanup, and cleanup, you can see, is just a stupid function that like remove the first and last characters and then split by double quote and then remove double quotes. This is here, for example, I don't want to handle, not here. This works as well, but here. This one is too big. Here, for example, I want to read it as one, not as string one. So I want to remove double quotes every time. This is the kind of transform that I want to have everywhere. And sorry, again, and afterwards, in some cases, I want it to be merged because, as I mentioned, here in my routes, I have something called the route ID. So here I have the route ID. So instead of just like loading that into memory, I want to have the full object in memory when I do my stream processing. So I don't need to do it every time. So here the route ID, the agency ID 11. So if I search for 11, even that takes a bit of time. Yes, here it's Schweizerische Bundesbahn. So I want, when I load my routes here, to directly have Schweizerisches Bundesbahnen in memory, so I don't need to look further. So this is the kind of stuff that I do. Afterwards, I will just write it down in the log because I want to make sure that it works. So you probably shouldn't do it, but for demo, it's very cool. And then finally, I write it down to the map of the same name. So that's what I did before to prepare the demo. And afterwards, this like stream data live is basically calling the web service. Not here, stream dynamic. This is easier to understand because there is only one call. And this is the pipeline. So I read from something called service. I've created like a mock data source just to be sure that it's easier if I don't have internet connection. Then I will get the timestamps because as I mentioned, the events, they probably have a timestamp. Here it doesn't play too much role, but it could in some cases. And I get the timestamp from the object, which is a JSON one. Then I will flat map the payloads into like different entities. And each of them, I will map them using trips. So basically, when you do map using IMAP, you are just saying, hey, I will get this object with this ID. So here I tell it how to get the ID from the data, the JSON data that is passed from this map, and I will tell it how to merge it with the trip. If it's a bit harder, if you need to do something more, then you have this kind of stuff saying map using service. So here I need to do a lot more than just like enriching it. I need to transform it as well. And so I have this map using service to merge with start time. Then I also, in the end, as I mentioned, I map the hour to timestamp. I will merge with location. This is very, very similar, if not exactly what I showed you in this slide. So basically, you can directly read the codes or directly read this slide. They are exactly the same. Again, I write it down in the log. I transform it to a map entry. And finally, I write it down in something called update, which is a map. And this map is subscribed by the final module. Where is it? Here. So when this clause is loaded, it will create a client. It will get the instance, the Hazelcast instance. It will get this map, and it will add an entry listener. And this listener basically, sorry, is of the type update map listener. So every time there is an entry that is added or an entry that is updated, then it will put that into the queue, and the queue basically will be pulled by this endpoint. So quite easy. Here I have a thread.slip because basically if I'm as fast as my backend does it, then my front end gets flooded at some point. So I need to throttle it in some way. So yes, this is the code. And again, it's available on GitHub here at this address. Are there any questions?
So yeah, about questions, let's do it now this way. We wait again, let's say in total 2 minutes for questions. If suddenly in 2 minutes there are no questions, then we kind of go in a break, which means we have 5 more minutes if anybody comes up with questions. And if it appears that totally everybody understood everything and therefore there are no questions, then we will start with next session with event. But usually there are some questions.
No, there can be 2 reasons for no question. It can be, as you mentioned, it was perfect talk, perfectly clear, everybody is happy, or it was very, very shitty talk and nobody understood anything, but they are afraid to ask questions, not to embarrass me. So that's not always good not to have questions.
Yeah, here's first question. Do you have experience with Microsoft-related big data technologies?
Not at all. I'm a Java guy or Kotlin guy, but Microsoft, I touched SQL Server like 20 years ago and never again. No, I don't use Azure either, so I cannot answer this kind of related questions. I'm sorry. I've been a consultant for nearly 20 years, and I was probably a bad consultant because I actually, when I don't know, I say I don't know. So no Azure and no Microsoft. Sorry for that.
But you really love Microsoft Teams, right?
What do I love?
Yes.
No, what do I love?
Microsoft Teams.
Joker.
I mean just today because of your with our experience, how it took all of your resource of your computer.
Yeah, I had some issue, let's say. I think Zoom is less memory hungry, but might be me. I don't know. Perhaps it was too hot or whatever.
So Microsoft provided us free license on Teams. Therefore, we are using it right now. Okay, here is the next question about Hadoop.
So again, I have no experience with Hadoop, but the thing is with Hadoop is you are doing batch here. You are basically doing batching and you are using disk. You don't keep everything into memory. So it's persistent. You have your resilient data sets, which is good. But basically, at that point, if you want to be very fast, it will be very hard to do Hadoop like this kind of demo. You can try doing it using Kafka or Hadoop, but it will be, I believe, much harder. Because again, you need to go back to disk, read from disk, and get back to memory again. So if you have everything into memory, and basically once the location has been computed, I don't care about it. So why would I store it on disk? So I'm not saying Kafka is bad and Hazelcast Jet is good. I'm saying in lots of use cases, you want to keep everything in memory and not go to disk every time.
Okay, we don't have any more questions right now, so let's go in a kind of official break time. So in 5 minutes we will switch to Ivan's talk. So if anybody has any more questions, ask to Nicolas. Ask them now. I'm just reminding.
Otherwise, you can send me direct messages on Twitter. So you can contact me on Twitter, and I will be happy to answer.
Okay, perfect. And just reminding, I dropped a link for feedback form. Please give us feedback. And as Nicolas mentioned in the beginning, if suddenly you didn't like his presentation, then please write some comment. Why so? And if you like, then you also can write some comment. Yeah.
Хорошо, благодарю вам и пока-пока.
No, not пока-пока yet, because let's wait a few more minutes. Maybe some questions will show up. Can you wait like 3 minutes?
I can wait even 3 minutes.
So let's try out 3 minutes. Usually while we wait till next speaker, then something shows up. Somebody comes up with some question. How is it, Nicolas? Are you afraid of silence?
I'm not afraid of silence.
Okay. I grew. Except if somebody says, if some guy says to you, пока-пока целую, да?
No. You told it. I was a bit impressed that how can a guy I don't know tell me целую to my face? That was super embarrassing.
But I said this is like I know how to compare with what this is like. If you say пока-пока, then it's kind of supposed to be the next thing what is in a year is word целую. So here is question. Can you drop a link for presentation?
Yes, I can. I will publish the slides on SlideShare, and I will tweet about it. So you need to follow me on Twitter.
Yeah, and if you can drop the link to us, then we will publish it together with video.
Okay.
Here's question: is Hazelcast open source?
Oh, come on! Yes, of course. I even had this slide about it. Apache 2 open source license. And of course, if you want to have support or to have additional features, there is this Hazelcast Jet Enterprise. But basically, everything that I showed you tonight is open source, fully open source.
I almost did a mess. I wanted to refresh another page and maybe did it here in a live stream. I don't know what would happen, but I am scared from the idea as such. Okay, seems that no more questions right now. Thank you, Nicolas, for finding time for us.